Hello everyone, I'm Abhinav Parhad, currently working as a senior software engineer at Observe.ai. Over the past few years, I had the opportunity to work on internal platforms that support our engineering teams from infrastructure automation to observability. My focus has always been on enabling developers to move faster with reliable and scalable foundations. Today, I'm very excited to share our journey building a 0 to 1 internal developer platform which is right sized for adoption and lean enough to avoid over engineering. This talk is for anyone who's trying to launch platforms early with real value and business. Here's what we'll cover today. First, we'll unpack why a 0 to 1 platform is uniquely hard. Then, I'll share the principles we followed and how we balance declarative and imperative tooling. We'll walk through the architecture, CI CD setup, and our observability stack that ships out of the box. Finally, we'll look at the outcomes and some lessons we have learned the hard. When you're building from zero, you're not just laying technical foundations. You're shaping how every team will build, deploy, and operate software. The choices you make, like picking declarative versus imperative tooling, can have long term consequences. Add to that the pressure for speed, multi cloud readiness, developer skill gaps, and the need for scaling. And it's very easy to get overwhelmed or stuck in analysis paralysis. Our goal is to cut through that with clarity and constraint. We committed to four guiding principles. First, start small and solve for one team. No platform should launch without its first users. Second, prefer convention over configuration. We made things work out of the box. Third, build modular. So we could replace parts without re architecting. And finally, automate everything, but only when it pays off. We avoided gold plating workflows until they hurt us. Declarative versus imperative tooling. This debate often comes up. Do we go all in on Terraforms or YAML? We chose to mix.
This is how it all comes together. Pulumi provisions the VPC, subnets, IAM, and an EKS cluster. It also deploys Argo CD and sets up external secrets. Once Argo CD is up, it pulls Helm charts for observability and app services from a Git repo and syncs them to the cluster. This setup makes everything reproducible. Spin up of new environment is consistent and safe. Pulumi became a foundational choice for us, not just to provision infrastructure, but to ensure it scales flexibly. One of the biggest wins was cloud provider abstraction. With the same Pulumi code base, we could provision EKS on AWS, but also have the potential to extend to GCP or Azure. Another powerful use was creating multiple EKS cluster environments like staging, load testing, production, all using consistent code pattern. This reusability gave us the ability to move fast while keeping environments consistent and compliant. Here's what a full Pulumi workflow looks like in our setup. Step 1, Pulumi provisions EKS cluster like PPC, subnet, IAM role, and the EKS cluster itself. Because we are using Python, we are able to write logic in real language, not just YAML or HLog. Step 2, we use Pulumi to install Argo CD via an chart. This bridges the imperative world of infrastructure with the declarative world of GitOps and application sync. Step 3, once Argo CD is up, Pulumi helps bootstrap our observability layer. This includes deploying secrets, service accounts, and installing Helm-based apps like Prometheus, Thanos, Loki, and OpenTelemetry Collector. What we loved here is that we could codify everything as infrastructure. It made spinning up a new cluster almost boring in the best way. On the Helm side, We used it for all application deployments. From our microservices to observability tooling, we created custom value file for different environments like values.load test YAML or values.staging YAML and so on, allowing config variation without forking charts. Helm gave us just enough abstraction to reuse template while remaining customizable. This separation also made ownership clear. Infra via Pulumi, apps via Helm, lifecycle via Argo CD. It allowed developers to contribute to the service lifecycle without worrying about low-level infra changes. We use Git action for CI. When a pull request is merged to main, we run tests on it, build a Docker image, and push it to Amazon ECR. Then Argo CD automatically detects the image change and syncs the deployment in Kubernetes. It's a clean GitOps loop that separate concerns and minimizes manual steps. Devs never need to access kubectl. From the start, we decided monitoring couldn't be an afterthought. We deploy Prometheus, Thanos, Loki, OpenTelemetry Collector, and kubectl by default using Argo CD and Helm. Every environment has metrics, logs, traces, and cost visibility from day one. This enabled debugging, governance, and capacity planning without devs asking for it. Our North Star was developer productivity. Developers don't care about platform. They care about getting their features out. We made sure that they had sane defaults, working CI/CDs, integrated observability, environment provisioning, all pre-wired. With this platform, new services can go live in hours, not days. That's the true measure of success. If I had to summarize our key lessons, first, avoid feature bloat, solve today's problem, not theoretical ones. Second, declarative infra wins for reproducibility. Third, observability should ship with the platform. It's a non-negotiable. And finally, treat developer experience like a real-world product with UI UX support and feedback loops. That mindset changes everything. Thank you so much for listening. I hope this gave you a real look into how zero to one platform can be both powerful and simple. I would love to hear your thoughts about platform journeys. You can connect with me on LinkedIn or drop me a line. Let's keep building better tools for builders.